Howdy folks, welcome back to CS 128 Honors. Today we're going to be covering enums and matching in Rust. So we're going to begin by going over what match statements are. They're a type of control flow similar to if-else, but they're more like switch statements if you're familiar with those. Then we're going to go over enums and what those are in Rust, and then cover the result and option type enums, a type of enum that you'll see a lot in Rust code, and finally go over control flow with enums and the match statement. Before we begin, a couple course announcements. So homework 1 is releasing today. It will be due on the 14th at midnight. Homework 2 is also releasing today, due on the 15th at midnight. And MP0 also releasing today, due on the 16th at midnight. We know that this is a lot of work at once, but we're giving you guys a week and a half to begin and submit these assignments. These should be relatively light, so feel free to reach out to us if you do need extensions. One more thing I want to note, homeworks will have a feedback survey attached to them. It's a question worth 0 points. You can type anything, ask anything to us, whether it be questions about course content, questions about homework or MP, and we will be going over those questions in lectures. And finally, extra practice problems are coming soon, so stay tuned for those. All right, so let's begin by introducing the match keyword. The match keyword allows you to compare a value against a series of patterns. We'll go over what patterns are in a bit. And once you've matched value against a pattern, you can execute code based on which pattern that value matches. So patterns can be made up of anything. Literals like integers, string literals, booleans, whatever the literal might be. And it could also be a variable name, I'll give you an example of that later, or a wildcard. It's just anything else. So the patterns you try to match must be exhaustive. So if I try to match every single integer, I must match, or rather, if I try to match an integer, I must match every single integer. I can't just match a couple integers that I want to and call it a day. You have to be exhaustive. So this is where the wildcard comes into play. If you want to match just a handful of integers, say 1 through 10, and then do nothing for the rest of the integers, you can use a wildcard to essentially match the rest of what has not been matched. So if you've used a switch statement in any other programming language that supports it, match is fairly similar to that. It's a lot more powerful though. It allows you to match patterns rather than values. Okay, let's get into this first example. I have some function getCourseNumber that gets me a number and assigns it to the variable course. Then I'm going to try and match course. So on the left here, I have a bunch of literals. All these are integers, and I'm going to try and match course against these literals. And then I'm going to execute some code based on that. So the code I'm executing here is simply just returning a value. So whenever I try to match course and I see 124, for example, this code's going to execute and return. So professor will have the value of Professor Challen if I see 124. And the rest, similar functionality. If I see 128, professor will have the value Professor Nowak. Now remember, matches must be exhaustive. So I'm matching some type of integer here, which means I need to match every single integer from whatever the minimum value is to the maximum value. So I'm using this wildcard here, an underscore, to match the rest. So if I don't know who the professor is, or the course is not listed, I can just return an empty string. And then I'm going to go ahead and just print out the professor teaches CS blank. Okay. Let's move on to the second example here, this string. So I have this function here that gets me a random string. It's some type of calling, and then I'm going to match that call as a string. So the thing to note, you cannot match capital S strings. You must match ampersand strings. So that's why we have this converting a capital S string to a str string. We'll go more on the differences between the two types in a later lecture, but just something to note. if you want to match a string, you have to match an str. So you can use this as str function to convert a string to an ampersand str. So again, we have literals on the left side here. If we see that call as a str is ILL, we're going to return INI, so response will have the value INI. Same thing to infinity and beyond, Hakuna Matata, Marco Polo. And remember, once again, matches must be exhaustive, and the number of strings you can create is practically infinite. There's so many possible strings you can create. So you're going to want to use a wildcard here to match the rest of the strings that you could possibly see as a call. And then we just simply print out the response. So there are more complicated match rules. So say, for example, you have a tuple, triple. You can match tuples or other patterns in various different ways. So let's say you have a tuple of 3 integers, and you just want to match the tuple 1, 2, 3. So if this triple is exactly the triple 1, 2, 3, you will execute this branch of code. You'll print out got 1, 2, 3. And we can use the wildcard here in special ways now. So if we see 199 in the first spot, 128 in the second spot, we can have anything in this last spot so that this code will execute. So any value here will print out CS128 honors, as long as we see 199 in the first spot and 128 in the second spot. Similarly, we can use the ... notation if we want to specify anything else follows. So if we see 128 at the very beginning, then any 2 numbers can follow because we have a triple, and we'll execute this third line of code. Finally, variables act like wildcards. So if I have any value here, any value here, and any value here that do not match the first 3, then we'll execute this branch of code. So rather than using a wildcard here, we're binding the value to a variable so that we can use the variable here. You'll use a wildcard like this, like an underscore, when you don't care about that value. But in this case we do, and we're going to add up the 3 numbers. Okay, I'm going to run some examples before we move on to this 4th example. So I have this repository of code. You can view this code in the GitHub linked in the description of this video if you'd like to follow along, but I'm going to be running through a couple examples. So back to the very first example with matching integers. We have a few integers here, and we're returning a string, or rather an ampersand str. And we get our course number from this basic function here. So if I run cargo run, then I see if course is 128, I get Professor Nowak, so Professor Nowak teaches CS128. I can change this to 124, and we'll see Professor Talon teaches CS124. And if I change it to something that is not in the list, say CS374, we get an empty string. This isn't really useful, and it can sometimes throw off your programs, so we'll go over a way that just sort of combats this empty string usage. Hint, hint, wink, wink. Okay, on to the next example with strings. Again, we have literals on the left side and ampersand strs on the right. So if I run this example 2, I have my call ILL, and that is matched here, and so we return INI. So if we try Marco here, we should get Polo. There we go. So call is Marco, and so we're going to return Polo. Pretty standard stuff so far. All right, on to our little triples example. So I have a couple examples here. The first is just 1, 2, 3, and so we should expect that this first line got 1, 2, 3 prints. go ahead and take a second to think about what the 4 remaining examples are going to print. All right, pause the video if you need to, because I'm going to reveal the answers. All right, so like we said, the very first example prints 1, 2, 3, or got 1, 2, 3. Second example, so we don't match 1, 2, 3. The first number is not 10, or rather is not 199, so 10 doesn't match. The first number is not 128, so 10 doesn't match again. So we're going to bind to x, y, and z. So x in this example will be 10, y will be 20, z will be 30, and we add those up to get 60. Okay, next example. First number here is 128. And you can see that that matches this third line here. So all we care about is the first position. We can discard the 99 or 999 and 0, and we print out, we only care that the first item is 128. And similarly, the CS199 128 example, that'll print out CS128 honors because we're matching just the first and second values of the tuple and discarding the third with the wildcard. Finally, another example where we only care about the first item here, so we match this third statement. Okay. Back to our example. So this is slightly complicated. There's a lot of complex notation going on. Let's just sort of go by each example at a time. So anytime you see this 0 ... equals 99, this is range matching. So any number between 0 and 99 inclusive will be matched by this. Okay. Then anytime you see a vertical bar, that's like an OR. So 128 or 225 or 341 will be matched by this line here. And again, we have a range matching. And then if you want to use a variable similar to the wildcard variables we used here on a range feature, you use this at notation. So your variable name and then at some range will bind the value of whatever number you have here if it is within this range. So if I have, say, some number like 201, in this example, level will now be 201. And then we print out, then we execute this little block of code here. So this is different from just the lines of code that you've seen in past examples. We can execute any type of code, any block of code that we want in match statements. So a block of code is defined by either a statement or some, wide array of statements within these brackets. So we're going to execute this if statement, and whatever value is returned by this if statement is going to be bound to message. So if we have the value 200, message will be 200 after executing this little block of code. If the value is, say, 350, then message will be 300 level after this line of code. Okay. And again, inclusive range statement, another inclusive range statement, and finally a wildcard to finish matching off the rest of the numbers. Okay, let's go back to VS Code and run this example. So I have a whole list of numbers here. Take a quick look and see what you think each number will print out. Pause the video if you need to. All right, here we go. So CS124, that is in our little range inclusivity statement here. It's between 100 and 199, so that prints out 100 level. CS128, that matches this little OR statement here. So CS128 teaches either C or C++. Okay, and then CS233, that will execute this little match statement line here. So 233 is between 200 and 399, and so the value that is between this range will be bound to level. And so now we're executing this if statement. Level is not greater than 300, so we return 200 level as the result of this else branch. Okay, 361, same thing again. 361 is bound to level, but level is now greater than or equal to 300, so we return 300 level. And then 225, part of this OR statement, same with 128. 341, also part of this OR statement, so we get teaches C or C++. Finally, 440 is between 400 and 499, an upper level elective. 10 is invalid because it's between 0 and 99. 523 is a graduate level course, that's in this inclusive match branch. Finally, 699 is invalid. Okay. So now on to enums. So what are enums? Enums are custom types with a restricted set of values. So this could be colors of the rainbow, an undergraduate student level, freshman, sophomore, junior, senior, day of the week, HTTP methods, whatever it may be. Your set of values that this type can take on is restricted. They make your life as a programmer a whole lot easier. So rather than having to deal with strings to represent days of the week, or strings to represent HTTP methods, or I don't know, I've even seen numbers be used to map to different values, you have a named type that represents this, and it can only be one of those specific named types. So enums are also considered patterns in Rust, which means we can match them. More on this in a little bit. So to define a custom enum, we use the enum keyword. So take days of the week, we have a restricted set of values, just 7 values that our type can take on, Monday, Tuesday, all the way through Sunday. And we can use this type wherever we want throughout our code. And so no other type except this set can be used. So let's see how we can use it in our code. We simply define a value of an enum by taking the type, day of the week, and then 2 colons, which is the scope resolution operator in C++, similar to that in Rust, and the value of the enum that you want to use. So day of the week, colon, Thursday. Okay, and I said we can match them. So enums are patterns, so we can use match statements and match statement operators on them. So we can match day of the week. If it's a Monday, we return a string UG. If we have either Tuesday or Thursday, this little bar operator, that's a day that we drop lectures for CS128 honors. Again, a bar operator for the weekends, and we can also use wildcards. So one thing to note for enums is, again, you have to be exhaustive in all the patterns you match. So if you're not using a wildcard, you have to list out each and every single one of these enum variants. So if I was matching every single enum variant, see, the only ones I'm missing are Friday and Wednesday. I would have to list out Friday and Wednesday here instead of using this little underscore operator. Okay. So Rust comes with a set of predefined enums for your convenience that the standard library API uses. So you'll be seeing these a lot all over built-in Rust code. So the first is the option enum. From the documentation, type option represents an optional value. Every option is either some and it contains a value, or none and it does not. So functions that return some type of option are usually not defined over some particular range. What does that mean? Well, when we have a vector that's a certain length and we try to get some index from that vector, the index could potentially not exist in the vector. So say we have a vector of length 10, and we try to get the item at index 20. Well, that index is not defined for that specific vector of length 10. So the index is not defined for that range of the vector. So when you try to get index 20 from a vector of length 10, your get function is going to return none. If you try to get, say, index 1 or index 0, you'll return, or the vector function will return sum, and inside that sum is some value that is located at the index. So this is somewhat similar to returning a null or a null pointer in Java or C++, none in Python. But the difference is that you have an enum. You're not having some distinct type to represent your none option. You have a enum that contains a distinct type. So the good thing about this is there's no more null pointer exceptions. No crashing on trying to dereference a null. Kind of. More on that in a bit. But you get a whole lot more safety by returning either a sum or a none instead of trying to just return a null pointer or none or empty string. You get some meaning out of an option type. So back to our little professor and course example, rather than returning an empty string, if we don't see a course that is recognized in our list, we can use an option enum variant of none rather than an empty string. And similarly, because we're using none here, we have to use a sum to wrap the values that we do know. So the return type of this match statement is now an option. Excuse me. An option that contains a value. So whenever we see the sum variant, that value is of type ampersand string, a string literal. Whenever it's none, there's no value inside it. So this gives us a whole lot more meaning rather than just an empty string, and it helps sort of make your code easier to read. Okay, let's see option in action. So again, back to that professor example, can run it with this, or rather. Okay, so we have a list of courses, 124, 128, 173, 225, and 361. And so what you can see is we're matching 124, we get professor is now a sum that contains the value Professor Challen. And once we have that value, we go down this if statement. And option comes with some utility functions. So is sum, is none. So whenever professor is sum, it's a sum value, we can extract the value inside it with this method unwrap. Use this with caution. So be careful. Only use unwrap when you are 100% sure that there is a value inside it, when it is sum. So if we're sure that professor is a sum value, we can extract the value inside it. So the name of the professor, unwrap returns a name, and we can print that out. And then again, there's the is none method. So if our option type is none, we enter this branch of the if statement and print it out. So one thing I should note, here we're not doing the unwrap to extract the professor's name. If you want to print an option type, you have to use this debug print statement, so : ? There's a lot of rules about printing and formatting in Rust that is outside the scope of this class, but anytime you want to print a custom type like option that is not formattable as Rust defines it, you have to use this : So this includes vectors, this includes certain structs, whatever it may be. So if your compiler throws you an error, like if I delete this, get an issue, there's no display formatting. Anytime you get that, try and add a debug format like that. Okay. Okay, so now the result enum. So the result enum is used for returning and propagating errors. What does this mean? So rather than just crashing your program when you have some type of error that you run into, say you can't open a file, you can't do something, there's some bad division going on, rather than just crashing the program, you can return a result. And you can handle the result by some custom handler code or whatever it may be. You're not crashing your program. Similar to not crashing your program with null pointers. This is why result is useful. So result is an enum with two variants, OK, representing some success, and it contains some value of type t, and error, which represents some error, something bad occurred, and an error value. So whenever you see a result type declaration, you'll see it as result, and then in brackets, t comma e. So t is the type of OK, e is the type of error. So functions that return result return errors that are expected. So you expect that some error could occur, something could go bad, and the error is recoverable. You always want to try and keep your program alive rather than just crashing and burning. So rather than just quitting your code, Rust makes you return result, which is a whole lot more meaningful. And one example of this in the standard library crate, result is most prominently used for I/O. So files exist, files might not exist. If you can't read from them, there's always some compatibility issues. Result is used for reading from files. Okay. And if there's no meaningful value to be returned as a success value in your result type, you can use the unit type, a tuple with no values, in the place of success or error. So if there's no meaningful value that you're returning from your function, you can put a little unit type as the t. So OK just means the function executed successfully, but there's no real return value. So we don't care about the result, we just care that it executed successfully. If it did not execute successfully, we have an error, and that error will have some string. Maybe that string is some type of result message that we can print out and debug. Okay. Let's see result in action. Okay, so I have some code here that is a custom divide function. So anytime I see that I'm trying to divide by 0, I want to give a divide by 0 error. Anytime I see that I'm truncating some decimals, I want to give a truncation error. So if my answer is between 0 and 1 and it's a decimal, I don't want to do that because I'm working with integers. Just suppose for the sake of this example. And then I have an enum that enumerates the type of errors I could get. So I have a fixed set of errors that can happen, and so I'm going to use an enum to represent that rather than either a string or an integer or whatever it may be. I have named types, named errors that I can use to represent things that go bad in my program. So this divide function is going to return a result, and success values are an integer, just the result of the division, and error values are this division error, the reason why my division failed. So if p is 0, we're trying to divide some value by 0, we have an error, so ERR, and inside it is the division by 0 error enum variant. If b is greater than a, then I have a truncation error, and otherwise I just return OK, the division is good, it's successful, and the value inside is the result of the division. So go ahead, run through this code, and think about what it's going to print. Pause the video if you need to. All right. So dividing by 10 by 0 is going to yield a divide by 0 error. Dividing 1 by 100 is a truncation error because 1 is less than 100. And dividing 20 by 4 returns OK. Okay. So some useful methods that you've seen in the option example is sum or is OK. Check if the value contains a value corresponding to some successful operation. These will return booleans. is none or is error. Check if the operation returning a variable of type option result failed. This again returns a Boolean. And then unwrap or. So this means either give me the value that corresponds to the success of the operation or some default value. So this is going to come very handy in your MPs. So another hint there. Okay. Use these methods with caution. So expect we are 100% sure that this operation will succeed. So extract the success value from my option or result. Otherwise, panic and crash the program if the operation failed and print out this message. And then unwrap, we are 100% sure that the operation succeeded. So extract the value corresponding to success and panic, crash the program if the operation failed. Avoid this as much as possible. It's extremely difficult and very annoying to debug. So this is just a fair warning for whenever if you want to use this on your MPs, try and avoid this as much as possible. Okay, one last thing. So like we said, we can match enums, we can also match option and result. So the patterns for your matches must be exhaustive, so you must match both some and none, or okay and error. And you can extract the value of success from your enum variants. And in the case of results, you can extract the value of the error. So in this case of sum, if our option is sum, we can say make value or val be assigned to the value of success contained in the enum and print that out. Same thing with okay, extract the value of success, assign it to val. If it's an error, extract the error value and print that out. Okay. Last example. So I have this match statement here, matching the result of divide. And if it's an okay, we're going to print out the result of our calculation. If it's an error, I have this division error enum. And then I can match that division error, like matching normal enum or normal custom enum, and return a message that corresponds to this enum error. Okay, I'm going to comment this out in my example, and we should see something similar. So 10 divided by 0, errored out, and it gives us this message, divide by 0. 1 over 10, errored out because of truncation, and 20 divided by 4 succeeded, and we have the result. All right, so I will cover the remaining content in a future lecture. This lecture has already gone a bit long, but that's all for this lecture, folks. Thank you for hanging in there.